what is the range of the function? So first of all, you have to ask yourself, what kind of function am I looking at? Well, let's say you had no idea. First of all, we should be able to see it's a quadratic, right? Everybody, it's degree 2. So then, let's say you had no idea. You could hit y equals on your calculator and type it in and look at it, okay? So first of all, I was able to see it's quadratic because it's degree 2. So then I said, okay, it's a quadratic in vertex form, which means graphing form. So you can look at it that way. You can say, okay, so I only need a rough sketch here. So we know that this is our shift right 4. This is your shift left and right. You always go opposite because that's what's added with x. And then we're going up 2. Is everybody comfortable with that? So we're going right 1, 2, 3, 4, up 1, 2. And then we have a smiley face parabola because that's positive. So I don't even need to be exact because I'm just looking at range. It looks something like this. If you don't believe me, type it into your calculator. So then from there, we're talking what's the range? Well, then you have to know what range is. Range is y values. So where's your function growing from bottom to up? What's the lowest y value? 2. And it's growing to positive infinity. Did it touch down right at 2? So it includes 2, positive infinity. Or if they said to you, state it as an inequality. What is range of y values? Wouldn't we say y is greater than or equal to 2? Okay, guys, get it right. You've got to get these right. How many got it right? Awesome. I did notice that you guys got it. Good. Okay. You guys, do you have questions on this? We've got to be able to recall things that we've learned all year besides just for the test that week. Okay. No questions on this? Okay, let's get going then. Today's a big lesson. So today we're learning the law of cosines. So the last 2 days we spent learning the law of sines. And why did we learn that? So that we can have a non-right triangle, we can still find missing angles, and still find missing sides. So we did know, though, to actually use the law of sines, you have to have 3 things. Either 2 angles and any side, or to use the law of to use the law of sines, you also have to have one acute angle as long as the side across from it is larger than the other given side, or an obtuse angle as long as there's a side across from it, and one other side. So let's say that we didn't have that, and we did run into that on the last worksheet twice, where we were like, we can't solve this using the law of sines, and you were true. So now we're learning the law of cosines. So once again, you can find missing angles and sides using the law of cosines. So we have a triangle that's non-right. So we have angle A, angle B, and angle C. And we know if this is angle A, isn't this side A? Sides are written as little letters. If this is angle B, this is side B. Side B is written as a little letter. If this is angle C, this is side C, written as a small letter. So here's the formula for the law of cosines. Same formula, just different orders. So understand a couple of things here. So we have side A squared is equal to side B squared plus side C squared minus 2 times B times C times cosine of angle A. So now notice something about this. Okay, everybody look up here. Do you see how this is side A squared? And then on the very end, we're looking at the cosine of angle A. So on the end, we're talking the side that corresponds with the angle. Do you see that? Now let's look at the next formula. We have B squared is equal to A squared plus C squared minus 2 times A times C cosine of B. Now look, isn't the extremes? This is side B and this is angle B that correspond. Okay? So do you see a pattern here? Same with this. C squared is equal to A squared plus B squared minus 2 times A times B times cosine of C. Look, this is side C squared, this is cosine of angle C. So you see how the extremes were dealing with the same angle that corresponds to the side. Okay, so the formula is not super hard to have memorized because there's just a couple of patterns like that. Also notice with this, so we have A squared is equal to B squared plus C squared, and then it's always going to be minus 2 times that side. So look right here, minus 2 times A times C. So that side times that side, and then it was minus 2 times A times B. So it kind of has a pattern. So now, what if I gave you PQR? You don't want to have to figure out where things go. So this is how I look at the formula, more as a general formula. So, if we're trying to find a missing side, I put MS for missing side. So missing side squared is equal to one of the sides given squared plus the other side given squared minus 2 times side 1 times side 2 times cosine of the angle across from the missing side. So they correspond. If this is the missing side, then the cosine of the angle across from the missing side, the extremes will go hand in hand here. So this is how I look at it, because then I don't have to memorize all of those and then try to figure out what's what. You know what I mean? Just like I don't memorize the Pythagorean theorem as a squared plus b squared is equal to c squared. I say side 1 squared plus side 2 squared is equal to the hypotenuse squared. Does that make sense, everybody? Do you have this down? Yeah? Okay. So, when do I use the law of cosines? To find some missing angles. So if you have 3 sides and no angles, there's no way to use the law of sines. But you can use the law of cosines, which I just gave you the formula. So if we have 3 sides and no angles, we can find the missing angles by using the law of cosines. Then also, if you're given 1 angle and 2 sides, where the side across is the missing side, so the side across from the angle is the missing side, you can solve the triangle using the law of cosines. Because remember, this is what we were running into on the day of the law of sines, something like this, right? And then we were saying, oh, we can't solve it using the law of sines, which is true. But you can solve it using the law of cosines. So given 1 angle and 2 sides, where the missing sides across from the given angle. So do you see how the missing side is across from the given angle? This is when you'll use the law of cosines. Which the law of sines is much quicker than the law of cosines, so anytime I can use the law of sines over the law of cosines, I will. All right, here we go. Are we ready? Okay. Okay, so we're going to solve here. So we're solving for x. So everybody look at the triangle with me so that you can make, I'm not going to say to you on the test that's coming up in 2 days, use the law of cosines. You're going to have to decide what to use. So look with me. We have this triangle, triangle ABC. We're given 2 sides and an angle. Now that angle is across from the missing side, so we cannot use the law of sines, so we will use the law of cosines. So does everybody see why I'm using the law of cosines? Okay, now let's just set this up. So now the formula is this, missing side squared. So wouldn't that be x squared? So we're going to go x squared is equal to side 1 squared. It doesn't matter which one's side 1. So 2.5 squared plus side 2 squared. So 3.5 squared minus 2 times side 1, which is 2.5, times side 2, which is 3.5. I should have left myself some room. And then we have cosine of the angle across from the missing side. So this is the angle across from the missing side, right, everybody? So that's cosine of 40 degrees. Yikes, I wish I would have left myself some room. Okay, so then from there, look at your equation. Aren't we just solving for x? Look at the right. Don't we have all that stuff? Can't we just type it into our calculator? So that's what you're going to do. Go. Type it in. So we have x squared is equal to what? You tell me. Type it in. Use parentheses as you see them. So we should all practice typing it in, because if you type it in wrong, you're in trouble. So let's all type it in. Here we go. Typing it in. So I'm going to write down the full decimal. You better make sure you get the same thing. 5.094222245. If you got that, you've done it right. Now we're just solving for x. So how will we get x alone? Square root. If we have x squared and we're solving for x, we'll square root both sides of the equation. So we have x is equal to, make sure you type in the full decimal when calculating something. So do second square root of second answer. It'll put in the whole decimal for you, so you don't have to retype it in. And now you can round your final answer. So 2.3. So x is equal to 2.3. Questions on how to do that? So it wasn't too bad, right? Let's do one more, really quick. So looking at this, first of all, some people would say, oh, that looks like a right triangle, but we never assume it is unless we're given that it's a right triangle. Well, that's 119 degrees, so it's not really purposely drawn to scale, right? But who cares? That is 119 degrees. So looking at this, once again, you'd have to ask yourself, am I using the law of sines or cosines? So we're trying to find x. We're given one angle and 2 sides, where the side across from the given angle is the missing side. Therefore, we have to use the law of cosines. So once again, This is the formula. The missing side squared, which is x squared, is equal to side 1 squared, so 23 squared, plus 20 squared, the other side squared, minus 2 times side 1, which was 23, times side 2, which is 20, times by cosine of the angle across from the missing side. So cosine of 119 degrees. And now you look and say, what am I solving for? It's x. Okay, awesome. So on the right, I don't have any unknowns, so I'm going to go ahead and just calculate it. So I have x squared is equal to, I'll just tell you. So x squared is equal to 1,375.024851. And then we would have to solve for x, but that's x squared. So we take the square root of both sides of the equation. So we have x is equal to 37.08. So we would round it to 1 decimal because we started, let's round it to the nearest, since we started with whole, let's end with whole. So that would be 37. So this side's 37. Questions on how to do that? We're all good. Okay, so I'm going to have you practice some off the worksheet and then we'll do some more. So you're doing 1 and 2. Now remember, we're using the law of cosines in these two examples to find a missing side. Okay, so now understand something. We just used the law of cosines to find missing side, a missing side. So we were given one angle and two sides, and we weren't given the side across from the angle. But now we use the law of cosine to find sides. But you can also use the law of cosines to find missing angles. And it's just, the algebra is a little bit more tricky. Same idea though, just like with the law of sines. But now we're just going to have to make sure as we go through and solve that we're really careful here. So I'm going to do all my examples off your worksheet to kind of help lessen the burden of how many problems, okay? So number 4, you're going to need paper for this. The algebra is a lot different with these. So everybody look up here. Once again, I'm not going to say to you, use the law of cosines. You're going to have to know that that's what you're going to do. So let's look. We're given 3 sides of a triangle and no angles, right? So you know I have to use the law of cosines. So then this is the formula. Missing side squared is equal to side 1 squared plus side 2 squared minus 2 times side 1 times side 2 times cosine of angle of the missing side. Now look up here. Was there any missing sides? No. So our formula is like, it might not make quite this much sense, but it hopefully will, because which angle are we actually missing? 13. We're trying to find this one, right? Yeah. So this is going to be the missing side, because that's across from the angle that we're trying to find. Because remember, they go hand in hand, right? Okay, so we're going to put 13 squared first. So we're plugging in what we know. So 13 squared is equal to side 1 squared, so one of the other sides squared. 12 squared plus side 2 squared, which is 16 squared minus 2 times 12 times 16 times that. Then cosine of the missing angle. So cosine of angle X. Is everybody comfortable with my equation so far? Now let's look at this one very carefully. Which piece are we trying to solve for? X, right? So it's right over here. So we're going to algebraically get X alone. So I personally have too many students make too many errors. So I'm going to just write it all out because it takes me an extra 5 seconds and I don't get them wrong. What is 13 squared? 169. So I really have 169 is equal to, what's 12 squared? 3, wait. Okay, let's actually just see, isn't this addition? Right here? Isn't this addition? Let's type that into our calculator. What do we get? 12 squared plus 16 squared. 400. Yep, so we have 400 minus, let's multiply those together. So you have 2 times 12 times 6. 16, sorry. 384. Okay, so we have 400 minus 384, and that was connected to cosine by multiplication, right? So do you see how I'm just simplifying it algebraically little by little? So now we're just getting X alone. The reason I do that is so that you don't add things where you're need to be dividing, and don't divide things where you need to be adding. So now to get X alone, algebraically, can't we get this 400 over here?
Yeah.
So we would subtract 400 from both sides, right? So we have 169 minus 400, and you get negative 231. So we have negative 231 is equal to, those add up to 0. We add those up, and we have negative 384 cosine of x degrees. Now here's where people mess up. They say, okay, so I'm going to add 384. No, how is that connected to cosine? Multiplication, right? Well, it undoes multiplication, division. So is everybody caught up to here? So we're going to divide both sides by negative 384. So then we have this divided by this, so we have 231 divided by 384, and a negative divided by a negative is a positive, so I'm just going to write it that way. And that's equal to, that's gone, we have cosine of x degrees. Now looking at it, how is x connected to cosine? Isn't it entrapped inside of cosine? The only way to undo cosine at this point to get x alone is to take the inverse cosine. So we're taking cosine inverse of both sides of the equation. So on the left, you have cosine inverse of that, and then on the right, cosine inverse and cosine cancel out. They're inverses of each other, leaving me with x. So you're going to type it in your calculator. Cosine inverse of that divided by that. Good, so x is equal to 53.2 degrees. So it says round to the nearest whole degree, so we will say that's 53 degrees. So we found angle A, 53 degrees. Questions on that? Now, couldn't we solve the rest? We don't need to. I'm just making a point, so everybody look up here. Now, if I said let's find angle C and B, couldn't we use the law of sines to solve for those? And that's a lot easier than the law of cosines, right? We say sine of 53 over 13 is equal to sine of C over 16. Do you see how easy it would be at this point to then use sines to solve for the rest? Okay, awesome. So we're done. One more, number 5. Then the rest of the time will be yours. So stay with me through this one so that you can get your algebra right. So once again, you'll ask yourselves, why am I using the law of cosines for this? Besides the fact that I told you this is the worksheet for the law of cosines. I have 3 sides and a missing angle. Therefore, I'm going to use the law of cosines. So once again, here's the formula. We have missing side squared. Well, we don't have a missing side, but you ask yourself, what angle am I trying to find? Angle x. So I put an x in there. And so this is the side across from it, so it needs to go on the outside of our equation. So we have 4 squared is equal to side 1 squared plus 10 squared minus 2 times 7 times 10, and then cosine of x degrees. So then algebraically, once again, we're going to get this alone. So we have 16 is equal to, I added those up and I got 149, and then I have minus 140. Cosine of x. So here's a common error. Let me just point out. People will take 149 and subtract it to 140. Can't do that. It's connected with cosine by multiplication. So now solving for x algebraically, we'll subtract 149. So we have negative 133 is equal to negative 140 cosine of x. Good. Divide by 140. Negative 140. So we have negative, we can even type it in like this. Negative 133 over negative 140 is equal to cosine of x. And now because x is entrapped in cosine, the only way to get it out is to take the cosine inverse of both sides of the equation. Inverse cosine and cosine cancel out. X alone, type it in. Cosine inverse of negative 133 over 140. Negative 140, or you could type it in as positives, it'll come out the same. 18.2. So that's 18 degrees. If we're rounding to the nearest degree, like the instructions say, 18 degrees. Okay, questions on how to use the law of cosines. Do your algebra correct. Do not do weird thingy-majiggies. Okay. So then you're not doing the whole worksheet. You're only required to go up to 11. I just did many with you. So really, it shouldn't be a huge burden on you because it's only up through 11. Ready, set, go.